Well, to start with this, I'm going to explain you what is the L'Hopital rule about. And basically, if we have a limit of a form, the limit when x tends to c of the quotient between two different functions, it results in an indeterminate form like 0 between 0 or infinity between infinity. However, the derivatives of that functions, the function f and the function g, exist and they are continuous near the value of c substituted in x. Then we will have the limit of the functions equal to the limit of the quotient of the derivatives. This rule is used mainly because when we are evaluating a limit, if we try to direct substitute, we will have an indeterminate form like the 0 between 0 or infinity between infinity. In this example, we have in the substitution we have the indeterminate form of 0 between 0, and this is when the L'Hopital rule comes in handy.
Well, how do we apply L'Hopital's rule? First of all, we have to check the form and ensure that substituting the values into f of x over g of x actually gives us a 0 divided by 0 or an infinity divided by infinity. Then, as a second step, we have to differentiate both the numerator and the denominator and take the derivative of f of x and g of x separately. As a third step and last step, we have to reevaluate this limit and compute the new limit of the fraction f prime of x divided by g prime of x.
We have the simple case that in this case we have the limit of x to 2. So first we substitute the 2 in the x and the result it will be 0 over 0, and this means that is infinitive. So we have the derivative of f and the derivative of g. The derivative of f is 2x and the derivative of g is 1. So then we substitute in the formula that the formula is derivative of f over derivative of g. So knowing this, we have 2x over 1 and we substitute the 2 in the x. So it's 2 multiplying 2, that is 4, so the limit is 4.
Okay, now exercise 2. This one will be a little more complex. Why? Because we will have to differentiate both functions twice. Why? I'll show you myself. Let's say the limit of x when it tends to infinity of e to the x over x squared is equal to e to the infinity over infinity squared. In simple terms, it's infinity over infinity, and that is not possible. That cannot exist. So we have to differentiate both functions so we can find the limit. The derivative of e to the x is the same, e to the x, while the derivative of x to the square is equal to 2x, meaning that the limit of x when it tends to infinity of e to the x over x squared is the same to e to the x over 2x. The problem is that e to the infinity over 2 infinity is equal to infinity over infinity again, and that is not possible. So we have to differentiate again. Now, the second derivative of e to the x is the same, but the second derivative of x to the square is 2, meaning that the limit of x when it tends to infinity of e to the x over x squared is equals to e to the x over 2, and that is e to the infinity over 2, meaning that the limit will be infinity. That's the result, infinity.
Okay, now we have some important notes. First, we have to know that L'Hopital's rule only applies to indeterminate forms that are 0 divided by 0 and infinity divided by infinity. Other cases, such as 0 multiplied by infinity, may require algebraic manipulation first. Number 2 is that sometimes you have to apply L'Hopital's rule multiple times. And number 3 is that we have to ensure that f prime of x and g prime of x are defined and also continuous near C.